All right, so let's try a couple more of these. And so once again, we're going to be in we're going to be in general form right here. And so we're going to have to find the vertex using this right here. Negative b divided by 2a will help us find x. Once we find x, we can plug it in to figure out the y value for our vertex and so on. So let's get to another example here. Okay, so let's go ahead and list my A, B, and C values. So my front value right here, my A value is going to be -1, B is going to be 2, and C is going to be 3. And so that formula for the vertex for the X value is -B divided by 2A. So I'm going to have negative, and then I plug in a 2 for B, and then divided by 2 times my A value, which is -1. So I'm going to end up with -2 over -2, which would simplify into a +1. So that's the x value for the vertex. And to find the y value, we're going to substitute the 1 into the function to find that. So let's see, when I square it, I get a 1, but I have that negative out front. So this becomes -1 plus 2, and then plus 3. So -1 plus 2 plus 3 is all going to simplify to a 4. So that's going to be the y value of my vertex. So I'm over 1 up 4. So that's where my vertex is at. Now this time my a value is negative. So that's going to cause me to open down. So I'm going to open down from here. And my axis of symmetry is going to be at x equals 1. That's what's going to have my symmetry for my parabola right there. And then let's see, let's find our x-intercepts. And so this will be factorable, but it is going to be kind of interesting. So let me go ahead and get this written down, and we can look at this. So for my x-intercepts, we're going to let f of x equals 0. So let's see, we're going to have 0 equals -x² plus 2 times x plus 3. Okay, now with the -x², that is factorable. I can factor that, but I really don't like that. So what I'm going to do here is I'm going to go ahead and divide everything by -1. So that's one of my properties of equality. So I'm going to divide everything I see by -1. And what that will do for me is cause a sign change. Well, 0 divided by -1, that will stay 0. But everything else, if it was negative, it becomes positive. And if it was positive, it'll become a negative or minus. So now I have +x² minus 2x and minus 3. And that'll just make the factoring process a little bit easier for me. So let's go ahead and factor this. So I got to figure out what multiplies to give me -3, but then we'll add to give me that -2 right there. And so it should be a -3 and a +1, right? -3 times 1 is -3, and those two numbers will add up to that -2. And so then you take each one of those and set them equal to 0 and solve, and so we should get a 3 and a -1. Those are my two x-intercepts. So at +3, here, 1, 2, 3, and then -1 right there. So those are my x-intercepts. Now up here, I have them in set notation right here, but I'm going to write them as ordered pairs because that's how you're going to have to do it on the homework. So ordered pairs, 3, 0, and then -1, 0 right there is my other x-intercept. Now for the y-intercept, that one should actually be pretty simple to get because you're going to plug in 0, and the only thing that will be left is that +3. So if I let x equal 0, -0² plus 2 times 0, those just get zeroed out, and I'm left with that +3 right there. So +3 for my y value. And so that's going to be right there. There's my y-intercept. And I can go ahead and reflect that across my axis of symmetry to get another point. And now I'll go ahead and do a little rough sketch here. Here we go. All right. And then my range, let's see. So I'm unbounded below, so that's going to be negative infinity. And then top, I have a boundary right here. I hit at 4. 4 is as high as I'm going to go. And there we go. There's my range. All right, let's try a couple more. Okay, so this one here, this one's going to be kind of interesting because my A value is 1, my B value is -4, and then my C value is basically 0 right there. I'm going to go ahead and add it on there, but it's kind of a little extra information there. So once again, to find my vertex, I'm going to have x equals -b over 2a. So I'm going to have negative and then -4 that I'm plugging in for my b, divided by 2 times my a value, which is 1. And so that double negative on top will become a positive 4 over 2. 4 divided by 2 is 2. So that's going to be my x value. And then now I have to plug that into the function to figure out the y value. So f of 2, so we're going to get 2 squared minus 4 times 2. See, 2 squared is 4, minus 4 times 2 is 8. 4 minus 8 is -4. So let's see, the vertex is going to be over 2, down 4, so about right there. And then my a value is positive, so it's going to open up. So we're going to open up. Axis of symmetry is always going to be x equals the x value from the vertex. And so that's going to be this little dashed line right here. And then for the x-intercepts, so for the x-intercept, we're going to let f of x equals 0. So we're going to have 0 equals x squared minus 4x. And then, so this one, we don't have a trinomial here because my c value is 0, but I can factor out an x here, and that should help me. So let's see, we factor out an x, and that will leave me with x minus 4 right here. And so once again, we're trying to figure out what makes this equal 0, right? And so the idea of factoring is now I have a product that's taking place, and if either one of those is 0, the whole thing will equal 0. So this first one, if I let x equal 0, 0 times, whatever this will be in parentheses, it doesn't really matter. 0 times anything would be 0, so that's one of them. And then my other one would be positive 4. Because if I plug in 4, this parentheses, 4 minus 4 is 0. I'd have a 4 right here, but it doesn't really matter. 0 times the 4 that would show up there would still result in 0. So those are my two solutions, and those are also my x-intercepts. So let's see, we have one right here at the origin at 0, 0, and then one over here at 4, 0. And so I need to put that here. So 0, 0 is one of my x-intercepts, and 4, 0 is my other one. And then my y-intercept is also going to be at 0, 0. Okay, because think about it. If I plug in 0 for x, I'm going to have 0 squared minus 4 times 0. That will be 0. And so now I'm good. I'm ready to go ahead and do a little rough sketch. And then we'll list our range. So then let's see my range. Let's see. I'm bounded below at -4. That's as low as I go. And then I go up indefinitely, so I'm not bounded. So infinity as far as how large it goes. Okay, so I think I got one more slide to go. So a little bit more of the same, and then I believe at the very end I do have a little word problem for us. So let's see. Looking at this, once again, vertex, let's see. So here's my A, my B, and my C value. So x equals -b over 2a. So I'm going to get a -4 over 2 times 1. So the double negative will become a 4. 2 times 1 is 2. 4 divided by 2 is 2. So there is the x value of the vertex. And then for the y value, we have to substitute that 2 into the function. So let's see, 2 squared minus 4 times 2 plus 5. 2 squared is 4. 4 times 2 is 8. And then we got the plus 5. So let's see, 4 take away 8 is negative 4. Negative 4 plus 5 would be a positive 1. So that whole thing should simplify to a positive 1. So let's look at this. So we're over 2 up 1. Okay. And so let's see, A is positive, so it's going to open up. It's going to open up. So if I'm opening up, that means I'm not going to have any x-intercepts. I'm not going to have any x-intercepts. Let's see, my axis of symmetry, I've got that at x equals 2. Okay, so back to my x-intercepts. As I said, we're going to open up because my a value is positive. So this is not factorable. So if you try to figure out, let's come down here. So if we set this equal to 0, so x squared minus 4x plus 5. So if you're trying to factor it, you're trying to figure out what multiplies to give you 5, but add to give you negative 4. You're not going to be able to come up with a combination that will do that. So what we could do is we could do the quadratic formula, but what's going to happen, like we saw in the second video, is I'm going to end up square rooting a negative number. And so this is on the Cartesian plane, we do not graph complex numbers. And so it will not work. And so just to kind of review that again real quick. So let's see, this is my, if we're looking at the quadratic formula, this is A, B, and C. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So just to kind of show you what will happen here. So negative b would become positive 4, plus or minus the square root. Negative 4 squared is 16. Then minus 4 times 1 times 5, which would be minus 20. All over 2 times a, which is 1, so 2. And so you'll see right away that what's going to happen is I'm going to get 4 plus or minus the square root of negative 4 over 2. And so, yes, there is a workaround using complex numbers, using the imaginary numbers right here. But once again, in terms of our graph, we don't have a way of graphing that in this particular plane that we're working with here. So we're just going to go ahead and put none, okay? And then the y-intercept will always have a y-intercept. And so once again here, if I were to let x equal 0, the first two terms are basically going to get zeroed out, and I'm left with that plus 5. So if I let x equal 0, I'm going to be left with a 5 right there. So we have a y-intercept right here, 0, 5. And then I can go ahead and reflect that across the axis of symmetry to get another point over here. And now we'll just go ahead and connect those dots and make a little bowl shape here. There we go. And then let's see my range. My lowest value is going to be a 1. Highest value, I don't have one. That's why we put infinity there to represent that it's going to increase indefinitely. Okay, so I have one left to go, but this will be a word problem, but it's going to be kind of similar to what we've been doing. The numbers might be a little bit messier, but I'm going to use a calculator to kind of help here. So let's see, NASA launches a rocket at t equals 0 seconds. Suppose its height in meters above sea level as a function of time is given right here. So the height is equal to negative 4.9 t squared plus 37t plus 127. So right here it says, how high above sea level does the rocket get as it peaks? Round your answer to decimal places. Okay, so what's going on here? I'm going to draw a little picture so we can kind of see this here. So the x-axis is actually going to be my time, okay? And the y-axis is going to be the height. And so what's happening is at 0 seconds before we even, shoot the rocket off, what's going on here? So at 0 seconds, we're actually at a height of 127 feet, or no, I think we're doing meters above sea level. So we're somewhere, I don't know exactly where we are, but I know that we're starting out above sea level, 127 meters. And so what's going to happen is the height that's going to increase as we ignite the rocket. So the rocket's going to go up, and it's going to come back down, and its height eventually is going to come back down. It might hit it might actually stop at 127 if we're on like a flat field or something like that. And by the way, this is not a picture of the rocket. I mean, it might look something like that as it shoots up in the air and arcs like that, but this is really the height and the time. And so what we're trying to figure out is, how high am I going to go right here? How high is that going to be? Well, the first thing you have to do is figure out the time that occurs. So you're trying to figure out, at what point, how many seconds go by will I reach my maximum height? And then once I find that, I can plug it in and figure out what the height is right here. So we're going to be using that formula for the vertex to figure out the x value. So the x value is equal to negative b divided by 2a. So you remember that formula for finding the vertex. So let me write that down over here. So negative b over 2a. And then once you find that, you can take that value and plug it into our function up here, and that will give you the height. The y value is the height, remember? So I'm going to have to use this value right here, my a and my b value. Okay, so let's see, x equals negative 37 divided by 2 times negative 4.9. And so at this point, I'm going to grab my calculator to help me with this. Now, when I put this in my calculator, I do need to be a little careful. If I'm going to type this whole thing in, I need to put the denominator completely in parentheses also. And the reason why is that if I don't, what can happen is the calculator will not read it correctly. So here we go. All right, so I need to put in negative 37 divided by, now I have to open a parentheses here, 2, you can press times or create another parentheses, negative 4.9, close it. So I had to do this. If I didn't put that extra parentheses, what would happen was it would only divide by 2, and then it would multiply by negative 4.9, and so that would be incorrect. And so I'll show you that in a second. So here, this is correct. It should be 3.78 seconds, basically. Now watch this. So second, enter. And so what if I remove that extra parentheses? So what happens is it only divides by 2, and then it multiplies by the negative 4.9. So you're going to see I'm going to get a much larger answer, 90.65. That's not correct. That's not correct. We want to use the top one there. So just be careful. Now, if you don't have a calculator like this and you're doing it in your phone or something like that, or maybe a scientific calculator, what you'll want to do is you could do negative 37 divided by, and you could figure out what 2 times negative 4.9 is first, which should be negative 9.8. So negative 9.8. And then here, if you do it that way, you don't have to worry about the extra parentheses. So put that in, And see, I get that 3.7755, so on. So you want to be super careful with your decimal places because it wants your final answer to be 2 decimal places. So what I'm going to do is I'm actually going to go 4 decimal places for right now, just to make sure I'm really accurate. So I'm going to put this as about 3.7755. Okay, so now what I have to do is plug that into the function for h. So h equals -4.9, and then now I'm plugging in the time. I figured out what time was. I figured out the time was 3.7755 seconds. That's when I'm going to reach my maximum height. And so see, I'm going to plug it in so I can figure out height. So 3.7755, then I'm going to have to square it. Then plus 37 times that same value again, 3.7755. And then plus 127. So once again, if you don't have a graphing calculator, which is fine, you don't really need anything, you know, you don't need a really expensive calculator. But if you're going to use like a scientific or whatever, some of the new scientifics are pretty user friendly, but you might have to put these in one at a time and figure out what they are and then add them together. But with the graphing calculator, you can just type this whole thing in. 3.7755, close that, and I'm going to raise it to a power of 2. And I'm going to do plus 37 times 3.7755, close that parentheses, and then I have to add 127. And I think that looks good. I'm ready to go. And so our maximum height is going to end up being 196, and I'm going to round that to 0.85. $196.85. Let me just double check, make sure everything looks good. Yep. All right, so rounding 2 decimal places, that looks good. And so that's why I added a couple extra decimal places, because if I took off those 5s, it might not round up completely. So I just want to be careful about that. And so that would be my answer. That would be how high the rocket, its maximum height right there. All right, so that does it for 3.1. If you have any questions or concerns, let me know.